The Ford Motor Company Windsor Casting Plant produces 160,000 clean tons of castings every year, including engine blocks, cylinder heads, and crankshafts. The plant has over 600,000 square feet of manufacturing floor area and employs over 950 people. Built in 1934, Windsor Casting has enjoyed an interesting history as a foundry supplier to both the war effort and the automotive industry. Through time, the facility has seen a number of continuous upgrades, including new manufacturing processes, computerized workstations, an on-floor plant information system, offices, conference areas, training center, and a new 25,000 square foot pattern maintenance shop. A statistical process control center collects and maintains all manufacturing process characteristics and provides networked PCs with online access to a year's worth of data. The system also performs automatic SPC analysis and notifies operators if any deviation occurs in the casting operation. At Windsor Casting, we're strongly committed to product quality and to the quality of our environment and our community. Prior to emission, about 1.2 million cubic feet per minute of plant air is filtered through high-efficiency dry and wet collectors. These filtration systems employ the best technology available. The plant's dedicated water clarification system also uses the latest technology to ensure that all discharged water effluent meets acceptable standards before being returned to the Detroit River. Scrap automobiles and construction steel, along with remelt iron, are used as raw material for cupola and coreless induction furnace melting. Accurate charge makeup is maintained to ensure the highest quality castings. The plant shell molding process for crankshafts starts with 10 shell molding machines and 5 bonding machines. The melting process has 3 coreless induction furnaces, which supply molten metal to the pouring area. Once a molded part is cast and solidified, it is conveyed to a double-station shakeout and shot pre-blast cleaning machine. Then it is sent to the cleaning room for cooling and despruing. In a more detailed look, both shell mold halves are produced by a shell core machine, which has been updated for better ergonomics. The 2-on molds have been increased to a 4-on process for greater efficiency. The 2 halves are glued together at a bonding press. To prevent breakage, overhead hoists are used to place glued shell molds into separate carts. They are transported and loaded into flasks. Each flask is loaded with shot and vibrated for compaction to ensure absolute shell rigidity during the pouring process. From one of the 3 coreless induction furnaces, molten iron is poured into a 1-ton transfer ladle to nodularize. The 2500 degree Fahrenheit treated iron is skimmed, checked for temperature, and metal composition. Then the operator transfers the iron to the molds, which travel on a double index line to facilitate pouring. After the castings solidify, they go through a shakeout process. A manipulator picks up the casting clusters and places them on an indexing conveyor to cool. They advance through a shot pre-blast machine, which removes external sand prior to delivery to one of 2 double-station despruing machines. The castings are conveyed to a finishing area where they are desprued, shot blasted, and trimmed. As the crankshaft clusters are desprued, the gating system and risers are returned for remelt. The parts are then loaded onto feeder pans, which carry them through a heligo shot blast machine. After shot blasting, the crankshafts travel on a walking beam conveyor, which feeds them through an automatic trim press. Then each one is automatically checked for runout. Next, the crankshafts are ejected onto discharge rails, where chippers remove any excess flash. Finally, the parts undergo a quality control inspection before being packed for shipment. Quality control inspections are performed on a routine basis. Components are checked to verify dimensional accuracy and proper characteristics. This ongoing data is statistically analyzed by a coordinate measuring machine, which allows for timely feedback of critical dimensions that are important for total product quality. Product quality is evident throughout Windsor casting with processes such as flow-thread treatment, which produces nodular iron for ductile iron crankshafts. A 1-ton treatment of iron is passed through the flow-thread vessel into a pouring ladle. To ensure consistency, samples are continuously taken and monitored for correct temperature and chemical composition before pouring. Statistical process control methods are used to keep metal chemistries within specifications. All chemical levels are automatically entered into the SPC computer. The results are then transmitted to the metal control station, where adjustments can be made as required. After sampling, metal is transferred and poured into green sand molds to produce 3 or 4 crankshaft castings per mold. A high level of commitment to quality is evident throughout the Windsor Casting Plant, such as in cylinder block core making. State-of-the-art Klein mixers mix the resin-coated sand used to make the engine block cores. The cores are produced and placed on a conveyor. V6 crankcase cores are advanced to a state-of-the-art automatic definning machine. After definning, they continue through a core wash flusher, where a refractory core wash material is applied to the core surface to prevent metal penetration. They pass through an advanced technology drying oven. As core components exit the drying oven, they are transported to presetter loading stations, where employees place them on a car track conveyor for delivery to the mold line. Another innovation in the core room is a totally automatic screw process used to join V8 jacket cores with slab cores. From here, they continue through core flushing and drying. The jacket and slab cores are located on an assembly pallet to allow for insertion of screws. The core assembly is then transferred into an automated screwdriver station, where the screws are tightened to proper specifications. Cores are transferred to the rollover station and inverted. They are checked for defects prior to flushing. From the flusher, the cores are advanced to the core oven load station. After drying, the cores exit the oven. They are drilled for venting and placed on a belt conveyor. The cores are then checked and transferred to a core delivery conveyor. The molding process consists of making drag and cope molds, drag flask set-on, automatic core setting, cope flask set-on, automatic pouring, and mold cooling. Prepared molding sand is dropped into a flask, which is engaged with a pattern. A hydraulic squeeze station compresses the sand, molding the cope drag cavities. The completed drag molds are transferred onto car tops. Online monitors continuously provide systems operation information so that operators have immediate access to system status. The core set preset cars travel to the automatic core set position, and the cores are automatically transferred into drag molds. The line is indexed to set the cope molds onto the drag molds and advance the assembly to the pouring station. An operator programs the system on the first molds of the day. It is then placed on auto pour for the balance of the run. An automated process takes a precise amount of chemically optimized iron from the furnace and pours a programmed amount into each mold. After pouring, the molds are transferred to a continuous conveyor for cooling and solidification. Windsor Casting uses a state-of-the-art finishing process, which can handle V6 or V8 blocks. The cooled cylinder blocks are shaken out and then transferred from a decline conveyor to a conveyor belt, which carries them to the finishing area. They are placed on a fixture conveyor that is set up for surface grinding. They are automatically rolled over. And the head surfaces are ground. When the grinding is complete, the block is run through an automated definner. Advanced soft logic enables constant monitoring of all facets of this multi-station machine. Ground and definned blocks are removed from the conveyor and sent through a 7-wheel shot blast machine. After shot blasting, the blocks are set onto a rail for shakeout to remove any loose shot or sand from inside the casting. Then they are repositioned for manual finishing. Each one is individually air tested, and random samples are checked on an online coordinate measuring machine. The blocks are automatically loaded onto a paint conveyor. Before shipping the finished blocks to the customer, each one is painted by an automated robot system. But the Windsor Casting Plant consists of more than just parts and machines. Our people are the ones who bring it all together. And in the interest of our employees, loading processes have been changed to reduce fatigue and eliminate discomfort. We've improved the ergonomics of our plant to make it a safer workplace. Makeshift work aids have been replaced with permanent ones that are ergonomically correct to do a better job and provide a safer, more comfortable work environment. We're also producing higher quality components, more efficiently and with greater regard for the environment than ever before. Advances that we're proud of. Employee empowerment has also played a significant role in contributing to Windsor Casting's success. More than ever before, employees' ideas are discussed and implemented to ensure that we are always doing the best job possible. To keep employees aware of up-to-the-minute mold line status, communication screens are located throughout the plant. Workstations are also equipped with visual aids to make it easier for operators to clearly determine when a part is acceptable and when it is not. To help maintain the quality of our employees themselves, the plant has its own fitness center. The center was designed and proposed by a joint employee management committee. Here, employees take pride in using a facility they helped design, while the plant has made a useful contribution to their long-term good health. To help everyone do their job more efficiently, Windsor Casting has also added a new training center that was built by the plant's own maintenance construction crew. The training center is used to provide everyone with the latest information on safety, continuous improvement, technology advances, and government regulations. Our new 20,000 square foot pattern shop enables us to perform maintenance on all plant tooling, patterns, gauges, and fixtures so that our products meet critical dimensional and quality requirements. Our efforts have not only helped us to run our plant more efficiently, they've helped us to earn the Preventive Maintenance Excellence Award, a sign of our commitment to quality. And when it comes to quality, we're proud to be a Ford Q1 preferred quality supplier and to be supporting the Ford Total Productive Maintenance Program. We're also proud to be moving forward with the additional production of 3.8 and 4.2 liter engine blocks for North America and the 4-liter single overhead cam engine for Ford's Cologne engine plant. We'll also be producing crankshafts for the 2-liter Zeta engine and the 3-liter and 4.6-liter engines. Though more than half a century old, the Windsor Casting Plant has kept up with the times and continues to be one of the most productive and profitable facilities of its kind throughout the world. It's a history we're proud of and one we intend to carry on long into the future.